Hey everyone, welcome to part B of the Object Motion series. Today we're going to take things a step further by creating cool and unique group motion patterns. We will code an object creator that generates moving or stationary objects in structured patterns. These patterns include objects set in a circle and a line. Unlike the last episode, which leaned more towards explaining the engineering concepts behind everything, this one will be strictly for coding. The mathematical background of this part will be in a separate video, so for those of you who enjoyed it, you can be rest assured that it's not going to disappear from this channel. Now without further ado, let's dive into Unity. We'll start with the moving object code we created on part 1. Because we need to set our parameters from the code and not from the inspector, our first order of business will be to create a setter function for each parameter. Technically, we could set these parameters to public, but that's generally not a good idea. So setter functions it is. Once that's done, we'll head back to Unity and create a prefabs folder. This will help us stay organized as we add more moving objects into future. Dragging our circle from the hierarchy into this folder converts it into a prefab, making it reusable like a template. Now, let's create the object creator. We'll begin by making a new C# script. The first step is defining an enum to make selecting a pattern easier. In this video, we will focus on line and circle patterns. Next, we declare new parameters using serialized field, ensuring that we can tweak them directly from the inspector. With this setup, we can now write the generateObjects method, starting with line formation. We set a for loop to run as many times as there are objects to create, where within each iteration we want to instantiate an object in its relative position, find its moving object component, and set it according to our desire. Begin with creating the current object's offset vector. The position has to be dependent on I, otherwise all the objects will have the same position and will be created one on top of the other. For a horizontal line, we make the X position depending on I, and for a vertical line we do the same but for the Y position. To have control over the spacing between the objects, we create a new parameter we called object distance, which we will multiply by the X position to control the offset size of each object. Next, we instantiate the object and make it a child of the object creator by writing its transform as our fourth argument of the instantiate method. We then get the moving object component and set its parameters using our newly created setter functions. Make sure to set the motion setter to equal the transform position plus the offset vector. Once we are done with that, I believe we are all set with the line pattern. Let's head back to Unity and create an empty object. Give it an icon so we can see it in our scene, and attach the object creator script. We'll drop our circle prefab in the object prefab parameter, set the other parameters, and I forgot to call the function again, didn't I? Classic. No worries. Quick fix, and there we go. We now have moving objects in a neat line formation. Isn't it cool? Later on, I'll show you how to create more unique motions in this formation, adding only one line of code. Next up, we have circular formation, and believe it or not, it's pretty similar to the linear one. We'll use the same loop structure, But this time, each object needs an initial theta value. If you recall from the last video, I showed you that the angle determines where we are on the circle. So we want all of the objects on the circle to do the same motion, only with a phase difference between them. That means that each object will begin the movement at a different point along the circle. That's why we need to calculate the current theta value for each individual object. Regarding the offset, we don't really need that for circular motion. But if we want to create a cooler circular motion, I'll show you that later, we can do a similar thing to what we did in the first part, where the x is r times the cosine of theta and y is r times the sine of theta. The next few lines are identical to the line pattern, with the only differences being in the motion center and theta. For theta, we initialize it according to the selected object motion type. We set its value to the current theta parameter for circular object motion, or to 0 for any other object motion types. For the motion center, the difference is that we don't need the offset, as I said before. Now I'll show you why we don't need this offset and what it creates if we do use it. If we are creating objects in a circular pattern that move linearly, it doesn't have any effect. But if we want our objects to move in a circle, we'll get this thing instead. Which is really cool in and of itself. You can either leave this offset or take it off. It is your decision and I'm not your mama. But if I were, I'd tell you to go clean your room. And definitely subscribe to this awesome channel. If we decide to delete it though, we get a normal, plain circular motion. Dang, why do I make it sound so lame? I meant awesome circular motion. Yeah, that's good. And we're done actually. That easy we created group object motion. Now I can show you other cool stuff with this code. We can copy the current theta line, paste it in the first loop, the one of the line pattern, and set the initial theta of the object to the current theta parameter we just pasted. This will result in some cool wave-like patterns. Experiment with different values yourselves. Maybe you'll discover a cooler pattern than those I've shown here. Alright, so that's it for this video. If you liked it or learned anything valuable, please consider subscribing and liking this video. Also, let me know in the comments what you'd like to see next. I've got some cool tutorial ideas for future videos, as well as a new devlog series I plan on creating. But feedback and suggestions are always appreciated. See you in the next one.